Alright guys, I hope you're being good for the sub. I want to give you a couple of reminders and help you do some of the hardest questions on your math that you have the least amount of practice with, okay? So pay attention to what numbers I'm doing for you. The first one, I want to just give you a reminder, you're going to do this on your own, but remember your decimal. This is a money problem. Remember to put your decimal point in. If you want to pause and do number 2 right now, or do 1 through 2 right now, so you can remember that decimal point, please do that. Right, now we're going to number 4. That's in our math book on page 249. And number 4 says, write the number of the shaded rectangles shown as a mixed number. And if you look at your book on page 249, you will see this. That is 3 whole rectangles. So we just write the number 3. And then there's a rectangle with 1 out of 6 pieces shaded. So this mixed number would be 3 and 1/6. Number 8. I don't want to do this one with you either. We've done plenty of time problems, but I'll give you a reminder. Please remember to count the minutes, then write those down, and then count the hours, okay? Because if you count the minutes, you might go past a whole hour. It's just very helpful if you count the minutes and then count the whole hours. Number line problems have also been giving us some trouble, so I wrote this one out for us. This number line is counting by 25s. If you had this one to do on your own and you didn't know what they were counting by, you can guess and check. Are they counting by tens? 510, 20, 30, 40? No, that's not right. 525, 50, 75, 600? Yes, that is correct. Which makes this one 25, 50, 75, but not just 75. It is 575. 575. And y is also 25, 50, 75, not just 75, 675. They also, this is a two-part problem, they ask us how much less they are. So subtract them. 5 minus 5 is 0. 7 and 7 is 0. 6 minus 5 is 1. So the difference is 100. Kind of went into the other box there. Let me write that here. Circle it. That is the answer. All right, let's do number 15. 15 is on page 250. And it's a square root problem. The square root of 36 plus the square root of 49. I don't know why I did that with my 4. Square root means what times what equals this number. What times what equals 36? The number 6. What times what equals 49? Number 7. Add up 6 and 7, and you get 13. Okay, flip your math paper over. We're also turning the page in the book to page 251. Remember, you can pause, rewind, do whatever you need to do. Number 25, I got confused on at first. 25 asks which one is not a $50. And they say A is 2/4, B is decimal point 50 with a cent sign, C is $sign with a decimal and 50 cents, and D is 50 with a cent sign. And when I looked at these for the first time, I said, oh, those are all $50. But there's one thing in here that makes that untrue. This decimal point right here says I have 1/2 of a cent. That is not half of a dollar. That is half of a cent. So the correct answer is B. That is not equal to half of a dollar. 26. If a rectangle is 5 inches by 4 inches, how do you find the area? We haven't talked about area very much at all. We're much better with perimeter. Area is when you multiply the length times the width. 5 times 4 would equal 20 inches. And whenever you talk about area, your answers are always squared. You can write it SQ. You might even see this exponent 2. Okay, so we're going to look for an answer A, B, C, or D that is most like that. And it looks like C says 20 inches squared. 27, compare -12 to -21. A lot of us want to say 21 is bigger. That is incorrect. You would rather owe somebody $12 rather than $21. So this is better, okay? This is more. B, we're comparing 1/4 of a dollar compared to 25 cents. Which one of those is larger? 1/4 of a dollar. If I have 4 quarters, I have a dollar. If I have 1 out of 4 quarters, I have 25 cents. So these are equal. That was a little bit of a trick. And 29 was very difficult looking. We've got a $1, $5, $10, and $20 bill. And it says list all of the ways to pair the two bills. And so what I'm going to do is I'm just going to write $1 and then comma. I want to have $1 with each of the bills. So $1 can be paired up with the $5 bill. $1 can be paired up with the $10 bill. $1 can be paired with the $20 bill. And now, the $5 bill. I'm going to draw lines so we don't get confused. The $5 bill, I do not have to pair with the $1 bill because we already have that pair. We do not need to repeat that pair. So the first pair I'm going to make is the $5 bill with the $10 bill. Next, I'm going to pair the $5 bill with the $20 bill. And now the $5 bill has been paired with all 3 other bills. Now I'm going to pair the $10 bill. $10 has already been paired with 1 and 5, so he just needs to be paired with 20. 20 has been paired with 10, 5, and 1, so these are all the ways to pair those bills. There are 1, 2, 3, 4, 5, 6 ways to pair those bills. 30, last one I'm going to do with you today. Turning the page, this is the only one on that page. 30, the state of Louisiana has 397 miles of coastline. Oregon has 296 miles of coastline. What is a reasonable estimate of the combined length of these coastlines? Why is your estimate reasonable? So 397 is almost 400. If something was $3.97, I would say, oh, $4. So I'm going to round 397 to 400 miles of coastline. $2.96, oh, that's almost $3. So 296 rounds to 300. And they want to know an estimate for the combined length equals 700. Explain, is this a reasonable estimate? Since 397 became 400, 296 became 300, these are reasonable estimates because we used our rounding skills to round these numbers. You don't really need to use words to explain that because we proved that in the best way possible using math, so you do not need to explain any further. Alright, keep being good for your sub, and I will see you tomorrow.